Oh my goodness. I just forgot to click the go live key. This is so useless. This is such a useless feature to have this key, to have this button. Why is starting the stream on the OBS side of things not enough for YouTube? I don't get it. I'm scheduling a stream. I'm clicking start stream using OBS on time, and the stream doesn't start on itself. I have to hit this key go live. It doesn't make sense to me. I'm sorry. Sorry for having. Sorry that I let you wait. So there have been a few theories from a few of my viewers as to why this missing letter issue might occur. A Warname has said that, oh, I don't have any viewers yet, so maybe it's not that much of a smart idea. I was waiting for this. So could get starting. Yes, I'm not sure if you have seen me talk yet. I was slightly annoyed by the way YouTube and its live streaming feature works. Okay, so I can start talking now. Excellent. So there have been a few theories as to why my entire Arduino setup is failing. So Warname had the idea that the bell wire that I was using is somehow acting as an antenna and causing some interference between the clock pin and the data pin. So we could in theory work around this by simply moving the pins around, so using another pin assignment, since the PS2dev library in its current state doesn't even make use of Arduino's interrupts. That's the second problem. PS2dev is making use of polling to get the PS2 host state instead of relying on interrupts, which is a bad thing on its own. Then a different viewer of mine, Tarsky is his name on Discord. His YouTube username also starts with task. He was asking, could it be a serial issue? So could you try it again with MoSerial? Maybe you did something wrong on the whole serial side of things, or maybe the key codes are wrong, which is something that I do not deem possible at this point. I think it's too advanced to be faulty in any kind of way. I was also recommended to take a look at PS2 Key Advanced, which claims to Arduino PS2 full support, protocol support, full keys, integer coding. So at first glance, exactly what I need, except for the information that oh yeah, this library allows you to exit the key code sent from a keyboard into its small buffer and read out the codes with simple methods. So exactly what I need, but the exact opposite of what I need. Unfortunately, but thank you for letting me know. So in my opinion, I could try this. I'm willing to try this. and I'm also willing to try this. Before trying to do any modifications to the PS2 dev library, I'll try to troubleshoot at here and there. But I'm very sure there's an interrupt and polling related issue, but I don't want to go that path down unless I really have to. So my viewers are right at this point. My viewers are basically right in the way of thinking. So let's move one of these pins without damaging things at best. Okay, where is it? Clock is still 2 and pin 5 is now data. Or no, the other way around actually. So what used to be at pin 3 is now at pin 5. Am I correct? Oh, hi Taskman. You've just been mentioned. Taskman, exactly. That was it. Tasky and Taskman. Thank you a lot. Thank you a lot for your advice and for trying to help me. And also, if you're still here, Warname, I know I haven't been very fair. I'm sorry for this. Also, thank you. So what used to be pin 3 is now pin 5. Exactly. Or is it? Wait, what? Two, three. Okay. Yep. Never mind. The library isn't being forcing. No, that isn't. The funny thing is, I just typed in that link you sent me on Discord, and I also had. I think I went through that library. I think I have seen that library at some point of the stream already, but I also forgot about it because the whole thing being just a passive receiving thing and not a sending thing. Never mind. Thank you regardless. Greetings. Greetings back. So this is changed. I'd also like to do the handle PS2 keyboard communication. I think the older code used to have some delay. The older code used to have some kind of kind of delay, so the actual original example code. But the ironic thing is I have deleted some part of that code because I always played around with that code because I deemed it useless. I deemed it unnecessary because in, you know, from a normie kind of view, I was assuming, why do you need to handle LEDs? Just send the characters. You know, things you do when you have no idea what you're talking about or working with. Another question. Oh, I need to get my gum out. The chewing gum. Um, is my audio quality acceptable? Because I realized after watching my own streams that I was way more silent and I was less louder. I was less loud than way less loud than the advertisement, which was the obligatory advertisement, which was essentially causing and being an ear rape victim of my own. So is my loudness volume, so my degree of loudness, is it okay or more or less? I would really appreciate that that advice. So it sounds pretty good. Like any other stream from. Okay, okay, good, good. I also did some acoustic improvement to my computer because someone yesterday someone asked me if I had AC on, which I don't. Mhm. So there's this time count, and then here's this. Ah, no. Okay. Okay. Digital right. Okay. No, no. My code is exactly the same as. But I have removed it a few times, and then I was wondering why nothing works because it doesn't pull the PST host state, and as long as there's no clipping from the audio loudness, it's fine. Okay. So if there's anything wrong or fishy about my stream's quality or the things I say or how the way I say them or the just the loudness and volume, just let me know. Hmm. Okay, everything seems to be fine here. I can get rid of this. I've changed the clock. I've changed basically everything. I'm so glad to have ditched the Arduino IDE. I'm so glad about this, so that I'm able to work in my preferred editor and not the Arduino nonsense, which is basically just obscuring everything behind uh, behind some pretty interface. I always tend to dislike this. So let's send another string. Oh, Nothing happening. Okay. But the issue of the first key code, you know, the shift key code, the shift key code is still being dropped. So if I'm, for example, if I would capitalize this, it would stay lowercase, because the first shift, the make key code for shift would not being sent, only the break one. So it can't be an antenna or interference issue. So I will redo the pin assignment real quick. Okay. Okay, awesome. So let's rebuild it once again. I still have the whole thing unplugged. Okay. Same issue. Okay. Interference doesn't seem like it. Okay, could it be a serial related thing? Good idea. So da, 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 da. It's getting even it's getting even worse. Like what? Can you talk about what most serial does? It's essentially just a serial terminal. So it's just a visual terminal, allowing me to interact with the Arduino serial connection. So the whole setup is the as of right now, I'm using this computer, the more modern. Tasman. Um, Tasman. You. Sorry, I thought you were a different viewer. In my opinion, most serial does the same. Most serial does basically the same as most serial does the same as my script does. This is weird. Most serial behaves even worse. Most serial behaves even worse than my script. But I can exclude it. I'm not sure as to why, but I can exclude that. I'm not sure as to why this is right now. So when switching back to okay, characters randomly missing, especially the first one. Some characters missing occasionally. Should it behave like that though? I'm not sure as to why it is. Maybe it's I have an idea. I have an idea. The thing is, I'm sending each of maybe most serial is sending each. There could be like a delay between those bytes, but I'm not sure. I know, but I'm sure. I'm very sure about this. That this is not a serial thing because I have implemented a feedback thing back then. So with each character sent and with each character successfully sent, so it was waiting for the keyboard state. So as to be seen. So it's reading the clock. It's reading the clock. So if handling IO abort is false, that's like there's like I essentially stole it and copied it from the library into the main code. And here's the keyboard handle thing and the keyboard handle function. We can see it. Keyboard handle, if available, read keyboard reply. The transmission is successful. I deeply believe that. I deeply believe that. So it's a USB connection. It's a USB serial connection. So I can't imagine. I really for real. I can't imagine any way that that something could fail from this side. I can't imagine. And the key codes are basically correct. The key codes are legit. But I will still keep this in mind. But let's I'm lacking absolute. I'm lacking the knowledge that is required to do something with PS2. I'm basically lacking the knowledge, which is basically why I'm even using this library for. And Taskman has recommended me to watch Ben Eder's video about this particular topic. Maybe I should do this, and maybe I should do this right now inside of that stream. I will refill my water bottle, and then I will actually learn something about the PS2 protocol, which up to this day, up to this very second, I never did. It's stupid. I know. I know. Oh, it's 30 minutes long, so maybe don't watch. Okay. Oh, if it's 30 minutes long, let's watch some other content. I think let's hope that we won't run into any licensing issues doing that. Build a PS2 keyboard from. So let's find a suitable video. Protocol and timing, device to host. Analyzing, capturing data. I think that's like the shortest content that's available on this topic. Device to host, host to device.
We now know that the PS2 sends its data as...
Sie sucht in den Datenmengen schon ewig Antworten.
So is the audio quality acceptable? Or like the volume, the desktop audio volume? I think the most interesting part is where it shows the breadboard with the LEDs. There are 11 LEDs corresponding to a byte each. explained it in the video not more so I meant it. Okay.
The PS2 Pro.
I assume this is gonna be a bit. I'll reduce the volume a bit.
Protocol allows a host to listen to a mouse or a keyboard and get the input from these input devices and interpret them to do something useful with them. It also allows a host to send commands to a mouse or a keyboard so that you can change some internal configuration. For example, you might want to change the speed at which the mouse is actually sending you data, or the resolution of the mouse, or the speed of the key presses on the keyboard, or something like that. Before I jump into the details of how the PS2 actually allows a host to send commands, I just want to remind you that the PS2 bus consists of only two signals. These are PS2 data and these are PS2 clock. So this particular diagram in here shows me several signals, but there are actually only two. The reason why we're showing you several signals is because I want to show you which of the two, the host or the device, is actually doing what to which bus. So in here, I'm showing you the PS2 data, the host, how the host actually when the host controls it, what does it do with it? And in here, I'm showing you the device, the PS2 data, but I'm showing you from the device perspective and what the device can do with it. The same goes in here for the clock. For example, the one on the top tells me this is what the host is doing to the clock signal or the clock bus, and in here it's telling me what the device is doing now. Okay, so let's dig in and see what the protocol does. So initially what we have is we have in idle, we have both of the signals, the clock and the D are actually high. So it seems to be in this diagram, I'm showing you that it's actually from the device, because most of the time the device is actually sending data to the host because they're input devices. So we're going to assume that the device is, generally speaking, in control of the bus. So when a host wants to send that device, which is a mouse or a keyboard, some command, what you need to do is you need to stop that mouse or keyboard from its activities. So you want to inhibit the activities. And the way you do it is actually the host takes first, what it does is actually goes to the clock and it drags it to 0 for about 100 microseconds or 0.1 millisecond. So during that time, no matter what the device is doing to the clock, it's going to be at 0 because it's connected to ground. And this indicates to the device that, okay, the host is trying to stop me from doing whatever because it wants to send me some command. And we can think about it as a request to send. This is how we can actually interpret this particular signal. So during that time, the clock is inhibited. So technically, you can think about it as the host is in control of the clock signal. So what the device does is actually releases that. That's how we can think about it. So at the same time, what we have is, because now the device knows that basically the host wants to send something, so the mouse or the keyboard knows that the FPGA board or the PC wants to send me something, so it will release the data line because it knows that basically it needs to listen to that data line, so it knows it. So what happens is it connects it, basically puts it into high impedance, and at that point the device actually takes over. And during that time, when the device takes over, it starts by setting the data line to 0, and this indicates a start bit. And during that time, at some point, the device takes over the clock again, because remember, the device is actually the one that generates the clock, not the host. So the host just takes it to 0 just to indicate that, hey, stop everything you're doing because I want to send you something. And then it releases it back, so the clock actually comes back and just says, okay, I'm going to generate the clock. And to the end, then it just generates the clock all the time. And then the device goes, or the host actually goes and says, okay, here's my D0, here's the D1, all the way to D7. So it sends that one byte that it wants. And also it sends a parity bit that it computes so that the device can actually figure out if it received the data correctly or not. Okay, so what we see in here is that the device, or the host actually, not the device, the host actually does everything on the negative edge, kind of like similar to reading. It also, when it actually shifts out a new data bit, it shifts it on the negative edge. So the host always is activated on the negative edge of the clock all the time. So the negative edge, negative edge, negative edge, it's always at the negative edge of the clock. That's how we have it. Okay. At the very end, when the parity bit is sent, what we do is actually the device issues a stop bit in here, basically drags it to 1 or drives the data line to 1. And this indicates to the device that, or the mouse or the keyboard, is actually the transmission is done, and it releases the data. It releases the data signal and it gives it back to the device. The device can It doesn't have to, but it usually acknowledges with a 0. So it drags that data line into 0, or the data signal into 0. And the host can actually read this if it just wants to make sure that that packet was sent correctly or whatnot. And then it just takes control over that bus again. Okay, from the here, basically the device takes control over it. What I want you to pay attention to is for how long does the host takes control of the clock signal. The host only takes control of the clock signal for a very short period of time. Again, the device is the one that generates the clock. We only utilize the PS2C on the host side. Basically, the host only takes the clock for a very short period of time just to indicate the RTS. And that is the reason why we have that PS2 clock is actually a bidirectional signal. It's just because of this particular thing, we need the host to actually send data on the clock, even though it's always receiving it. It's just for that particular signal. Other than that, you can actually take a look in here. The data, when the host is communicating or sending data to the device, you will see that the data is mostly under the control of the host, mostly. So it's only when the request to send and the stop signal where it actually takes care. Like basically, the device only takes the data line or the data signal only during the request, or only before the request to send, and only at the stop bit, and that's it. The rest of it is actually the host is in control of that bus.
Okay.
Ich habe 2016 bei Lufthansa angefragt.
Shut the... The clock signal is generated by the device. The device is responsible for providing the clock pulses. Ich relies on. Wurzel, aber warum? But why he's saying. I fully get you. I totally get you, Wurzel. I will redo this. And then restart that whole thing to see if simply ones do appear. Okay. Taskman, what was your input in most serial? So what I have here is the following. The script, this PHP script, what it does is it's generating the key codes for a certain string, so for the command line argument. It saves these key codes into a file before sending it in, the file recent.bin. And when doing view hex recent.bin, hex view, so that was the thing I was sending. So I was basically sending the thing that I intended to send in a hexadecimal format. Oh, look at this. Oh, have you seen that? Have you just seen that? It had a hard time. This thing had a really hard time getting the first ones, the first ones sent. It had a really hard time, and then just all of a sudden 1111. So is there like a buffer? Is there like some kind of a buffer that is all of a sudden being injected? The interesting thing is, if I would replug that thing, I've seen that issue. I've seen that issue occur. I know what it is. I've seen this issue already occur on that laptop. On this laptop using this USB PS2 USB adapter. This doesn't occur with the Toshiba laptop. So this first bit problem seems to be. This first bit problem seems to be or first byte problem, rather, seems to be specific with the adapter. So there seems to be some inconsistency in the PS2 protocol implementation. And at this point, I know the stream is going to be boring. The stream is going to be very boring because the only thing that I will do now at this point, is debugging the shit out of it, the living shit. I will try to get the clock signal. So if there's like a clock signal being initiated from the PS2 host to the Arduino, I want to see it. I want the Arduino to tell me using the serial bus. I won't allow this PS2 dev library to dupe me, to fool me. what if we get rid of this weird digital write thingy? Okay, issue persists. Issue persists. Okay. Okay, this seems to be a continuous stream of zeros. Okay, 2e. So there's at some points there's like this 2e appearing. Does this 2e thing have any particular meaning? keyboard reply. And it still does. So there seems to be this 2E thingy going on. So there is a host communication going on. I'm curious if it would be the same with the Toshiba, and I will find out. So maybe there's like a slight difference in with the PS2 adapter. Because the PS2 adapter definitely has a different behavior than the Toshiba satellite. So maybe it could be like an inconsistency. But inconsistency is the wrong word, because my Model M, for example, that I still have disconnected because I need to have the USB PS2 adapter on the laptop. It works fine regardless, with a native PS2 port or with the adapter. So the library must have some kind of inconsistency. So it's not fully realized. It's not fully made. It's not fully finished. And it has existed since 2008, which makes me even more angry that nobody really took the time, or maybe someone did and realized there is some technical impossibility. I better hope not so. But I'm really glad to have this plastic box, to have it in some kind of shell, so I can be sure that I won't lose any contacts while moving that thing. One. So as you might see, this works somewhat reliably compared to the compared to the USB adapter thingy. So let's. Okay, 2E, 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 2E. 2E, 2E, 2E. 2E. Okay, the very same thing. So the keyboard state is definitely changing. So at this point, I just feel like debugging the whole clock signal thing. To implement some kind of interrupt and then have the Arduino tell me using the serial line. So where does it try to obtain the keyboard state? That's what I need to know. So it's either keyboard handle or the available method that needs to be called continuously. That's what the documentation says. Or available. So it performs a digital read of the available method, returns whether if either the data or the clock are low. Okay. I don't even know how this Arduino stuff works, if I mean to be honest, when seeing this void loop or void setup stuff. So is this... Serial event occurs whenever new data comes in the hardware serial RX. This routine is run between each time loop runs, so using delay inside loop can delay response. Is there some way to... What? So it relies... So it's just a thing run after the loop? I will replace that keyboard. My fingers start hurting. I will get rid of this useless thing. It's annoying. Don't use rubber dome keyboards. My fingers start hurting. So there is alt soft serial.h. Why do you want to use an interrupt anyway? The serial hardware already generates an interrupt and inside that ISR the incoming byte is placed into a buffer. I have an assumption. I have a feeling what the problem is. My assumption was that serial available was once sending the serial stuff, once sending the serial data, once there's a chunk of serial data being sent, the library and the library's continuous checking of the keyboard state is being ignored, and there's just data sent. That's what my assumption is. So there is no checking to be there is no checking being done because of the way my code was written. So instead of a while, we could do a single if. And for some reason, the delay microseconds byte wait has been commented out. Maybe I can uncomment this and get this thing to work. And it was uncommented for no apparent reason. And there also is byte wait. Delay between bytes. I found that I need at least 400 microseconds to get this working at all. But even more is needed for reliability, so I have put 1000. So delay microseconds is basically everywhere except for the available state, which is weird. So this is the default state. So this is the library as it is. So I haven't made any modifications here yet. Wait, what? Keyboard was not declared. Ah. Okay, nothing happening. something happened. But still unreliable. Okay, still unreliable. But what's weird, I find this particularly weird. So if I do keyboard available instead, okay, never mind. Okay, we have missing characters, we have characters reappearing, we have okay, we have all sorts of weird stuff. Okay, let's re-implement. So let's uncomment what they commented out. So let's respect this. So let's do the delay microseconds part. Okay. So things are still missing. Okay, never mind. So what if we get rid of this? So it doesn't actually do anything. So it's just a return value. So it doesn't wait for anything. Okay. So I can. So since there isn't nothing being waited for, or what can I do? Oh my goodness. Oh my goodness. Oh no. Still stuff missing. There is still something missing, but I feel like this is way more reliable than what it used to be. Okay, there is a buffer related issue. There is a buffer related issue. So there is a maximum size. This thing got a maximum size. So there is like a limit in the inside of the serial buffer. So I need to have some. I need to implement some kind of feedbacking system between the computer and the Arduino. But we got very far. We got very far this far. This is awesome. Okay, we have 5, 10, 5, 10, 20, 21, 21, 21 times 3. No, Moment. Let's calculate the buffer size. Let's calculate Arduino's buffer size. So we have this much amount of characters, including the enter. that's automatically being entered. So we have 21, 22 times 3. This equals 66 bytes. Why is it 66? Why is Arduino's buffer size like 66? Or is it 66? But let's keep it to 64 bytes. So maybe things are already being worked down, and so there is this thing. I'm also curious if now reintroducing this thing right here, if reintroducing the microseconds delay thing, if this does something. Okay, there has already been like an error. So with the microseconds delay, which used to be in the code but then was commented out by the library developers, so we don't even need to go this is awesome, we don't even have to go down the interrupt rabbit hole. What if we do seems way more reliable. Yeah. Let's do the 400 microseconds delay. So, but for some reason the first sequence always being not sent. So but never mind, we can work around this. But what could the issue be? Charge. Mm. Let's measure the time. Now that this is done, let's do some time measurement. So it was an issue from my side the entire time. The problem actually sat in front of the computer because I've been using the library the wrong way, because I've disallowed the Arduino to do the keyboard state checking, to check the clock and the data line state, since I was sending all of that stuff in one go. Of course this couldn't have worked. But I'm sure I can. This can be way much faster when an interrupt is being used. So I still have the interrupt idea. I have the interrupt idea still in mind. The interrupt idea is still in my mind. So once the buffer has run out, so I'll do a check. I will do a check. So once the buffer has run out, so if there's no more serial data available, I want it I simply wanted to say 255. So now the send function, I have to redo it a bit. What do you think? How long would it take you to create a quick and dirty interrupt durability check? Quick and dirty interrupt durability check. I don't think it would be that much. I think it would be like a four-liner and the research that is tied to it. But I need to redo my PHP code now that I know that there is a buffer size which needs to be respected. So I need to wait for the Arduino's feedback once the buffer has been emptied. Or maybe once the buffer... Yeah. I'm thinking a large buffer size on the Arduino would help a bit with performance. Just load the letters into the serial buffer from a bigger letter buffer once the serial buffer has been sent. Yes, that's a good idea. That's a good idea actually, to put that stuff into a larger buffer. But I actually feel like that the serial speed, like the USB serial speed, is always beating the PS2 bus speed, no matter what. So I'm sure that I can do it the inefficient way, because it wouldn't matter at in the end result. But let's verify the theory. But the thing is, I will do it. I will do it the inefficient way first, because I feel like it gets me closer to the goal. And when I feel like, so the rates are the rate is somewhat the same. So if we would exclude the whole interruption things from the PS2 host side, this is going. The speeds are somewhat the same. Also considering. I think it's basically the same. I think it would be an improvement. It would be an improvement for sure, but I think the gain is not worth the time that would take. Chunk size of the chunk size. Why is that? Why would you go for the 63 bytes instead of the 64? Well, but 3 bytes per code. But the thing that's supposed to be splitted is already the thing that is supposed to be splitted is already the sequence consisting of the codes. Or do you feel like there could be like a certain event where there is a make key sent at the end of one chunk, and then the break sequence is the beginning of the next chunk, resulting in some kind of delay, which causes some keys to be which causes a certain key to be so in the eyes of the PS2 host being pressed for a specific for a longer time. Is this what you think? Huh. This is it doesn't sound wrong. It sounds, this sounds good, but would this make sense? Would this make sense? There is a problem. There is a slight problem in your calculation, because the chunk will never be 63 bytes, because it's inconsistent. Some keystrokes, some for example uppercase characters or a sequence of uppercase characters takes Taskman is 64. But the problem is it isn't divisible by 3 always in the first place. So it's not a thing of predictable manner. If you get the idea. So you can have the size 64, but you might need to send the buffer before it's fully saturated. So you can have the size 64, but you might need to send the buffer before it is fully saturated. Huh? But I'll test it. I go for the I go for the no brain chunking, the always 64 byte chunking approach. And if it should cause any issues, in the long run, I consider a different approach. Are there any key codes that I am not transmitting? So what is what is 255? I'm realizing another issue. So is FF hexadecimal, does it have any kind of meaning? Special offers and affiliate program. So there's no reason for a keyboard to send FF. Okay. Oh. I don't know. Oh. Will it not just send the same character for every clock cycle from this point onwards? Yes, it will basically do that. So I'm thinking of some kind of strategy to mitigate this. Never mind. Maybe stop the clock cycle somehow. Seems this would reduce it when it starts back up again though. It's also my assumption. I assume the very same thing, but I will try it. I will try it because it's like the no-brain approach. Line 195. Ah. Okay. I feel like having to send some random stuff during the initialization. Oh. Line 26 and huh. You don't have to implement this if you can get it working the wrong no-brain way. I think there are some clear good advantages of doing the translation from string to serial bytes on the maybe. Yeah. I get your point. I totally get your point. What's the problem? Is this like a hardware issue or is this a code issue? So it's looping, then it does its delay, then waits for keyboard available and if serial available. You don't even have to store a hex string for most of the time because you convert. You don't even have to store a hex string. Well, the hex string is just for debugging purposes. So the data through this serial interface is sent as binary. So this is not a hex thing. So it's basically just for using Mo serial because because Mo serial is using a hexadecimal interface. Huh. Does this sleep? Does this go to sleep for some reason? So I have the assumption that in the if statement, this is first being run and not this, and for some reason it causes it to go to sleep and okay, left to right. Method 1 called first, and its result determine the Okay. Then the advantage come down to the binary data being a third of the size on the Arduino, as the break bytes could be added on the fly. Also, the buffer can be set. Huh? But still, maybe I believe there could still be some kind of overflowing issue. Because when the keyboard goes idle, when the PST host goes idle, and then is being bombarded with data, with serial data. Is it? I'd stick to the no-brain thing. And why does it fail again? This is weird. I definitely have to go for now though. Okay. Have a nice day or have a nice night wherever you are located at. So is this like, why doesn't it react to anything anymore? Is this like still a code issue? There still seems to be a code issue that I don't get yet. Keyboard handle. So okay. This is weird. Maybe this? Could it be this? don't get this. I don't get this at all. Why has it stopped working? So there is feedback. Oh! What the fuck has just happened? This didn't sound good. Oh. Sound like that super fast for some reason. But I don't get this. There must be something wrong on the PHP side of things. Not the PHP side of things, but the serial side of things. Oh. Oh. I know what it is. I'm able to... the Arduino is crashing the Toshiba because it's being spammed relentlessly with ones. Okay. I know what the issue is. I can't have the break in. I can't have that break. So I can't have that weird waiting thing going on here. I believe that is. Or was it just an illusion? But I'm able to crash it. if I go like this. Mm. Okay, interesting. So the keyboard available checking in itself is not sufficient. Okay. There was a serial print in that piece of code. What was that for? The serial the serial print. The serial print was just it was just copied from. It was just copied from that code. Oh, could it have been this dot? Could it have been this dot? Oh my goodness. Of course it could have been the dot. Oh. Okay, this is interesting. This is somewhat interesting. This is interesting. This is weird. This is weird. The first serial connection is always being dropped. The first serial connection always seems to be dropped by the Arduino. So let's unplug the Arduino. Wait for it to turn back on again. Oh, it turned on again on its own. Uh, I have some port related issue. Okay, it seems that I have to use TTY ACM for the time being. TTM ACM 1 for no apparent reason. Ah. Okay, I have to do a certain thing. It's as if the connection processing out as if it expects something else, some initializations parameters, and if it connects it is probably. Awesome. 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 Yes, I need to make it faster. And by making it faster basically means making it faster basically means not doing writes or maybe doing writes, but I shouldn't do single writes. I shouldn't send single bytes. I should rather use I should rather send whole break sequences. I need to follow some good advice. I need to follow the taskman's advice. I need to do the conversion inside of the Arduino. Is the connection? Make it faster. Use more ChatGPT. Why should I? Why should I want to use ChatGPT if I already got a if I already did the same thing in PHP? I simply need to make a few changes here and there. Oh wait. That means okay. Okay. Um. I have a different idea. Maybe I can. I could do a different approach, which could make it faster. think I do the I need to the only reasonable way for me to do this is to make the conversion on. I need to make the conversion on the Arduino. So can I send this stuff in one shot without having to fear some kind of buffer overflow? That's what I'd like to find out. Let's make this really. Oh. Okay, it seems that it doesn't have a buffer issue. If this would be the speed, so this would basically, right here, what we are seeing, this would be the actual typing speed. So if we would follow the, if we would do the conversion from a string to the actual PS2 key code sequences, this would be the speed. And we don't need to chunk anything on the PHP side of things. Fast enough. Basically, yes. It's still lighting up like something. This is cool. Can I also do the same using... Could I pipe... I'm going to pipe doom.zip. I can abort it, of course. So it's blinking. So I'll definitely be able to send Doom. Or do you mean? Or do you mean no? This would be the speed. This would be the speed. So if we would, if I manage to do the conversion from a string to PS2 keycode sequences, this would be the speed. But why is it? Never mind. Oh, it's C2I ACM0 again. What? What? Shouldn't it? Why does it? Why does it keep sending stuff? Ah, I get it. I forgot a crucial thing. I still need to read the character. Okay, awesome. Can I also have it reply? I think that's a Linux related thing. So when unplugged and replugged in a too quickly, the assignment still stays there for TTY-ACM0, so it still exists, and a new device file is being created. Oh. So it seems as if I can't bombard it. So I can't bombard it at once. So I still require some kind of feedback system. PS2 is only 10 baud max, yeah. What? No way. No way. I just realized I had the fucking thing unplugged for I had this thing unplugged for 10 hours straight. The laptop was unplugged for 10 hours straight, and now all of a sudden it started beeping. Okay. No, not 30 years old, but I think it's I got it from Poland, so I specifically ordered this thing, but I'm surprised how energy efficient this thing is. Which laptop nowadays is able to survive for 10 hours? Eight, 16, 32. Eight bytes, 16 bytes, 32 bytes. Huh. What happening here? I'm just trying to debug Arduino's way of handling a serial connection. No, it isn't. It isn't. I feel like just doing a cat, like just doing a cat thing. So if I manage to be slower, so if I manage to have a slower baud rate than the PS2 interval, maybe maybe that's a better idea. Can you bombard? It says see begin. Well, that's what I'm trying. So I'm setting up the port and doing half of it, and then reconnect. What? let's do 600 baud. And also here, $300. Okay, no reply. It used to be better, so maybe we can do like I can't do 500, and 600 is already bad enough, it seems. Oh, okay, I need to be fast. For some reason I need to be faster. But how can that be? Does this make sense? What if we would try to bring that up? I don't think that maybe you have a different perspective. Changing the baud rate won't solve my problem. There's always gonna be the upper limit. So if let's go to the upper limit. Let's go vulgar. Yes. As I assumed, there's always gonna be the upper limit. So the baud rate won't solve a problem. But I should use a baud rate which is that's faster than PS2. That's for sure. Oh. That's interesting. The Arduino's upper limit in terms of baud rate is equals the PS2 protocol's baud rate. Why? And how? And for what reason? I have a hard time grasping this. Standard oscillators. Probably. Do you know what? I'm glad to have solved this. I am glad to have solved the PS2 communication problem and have reliable PS2 communication. And now, like the steps involving the improvement of the speed improvement is. You need that you need that clock crystal. Did you write clock? The Arduino is a weird boy. I'm very sorry, especially to VJ Codec. I feel like I have to leave. I feel like I have to leave. I'm just glad to have solved the communication problem, to have some reliable communication, and the whole speed improvement thing and the decoding of string to PS2 key codes. That's going to be like the 5th stream. I'm sorry. Thank you guys for being here.